Okay, so we're going to do a couple example problems for definite integrals. So our first problem here gives us the definite integral from 1 to 3 of 2x dx. So the first thing that we need to do is we need to take the integral of of 2x dx. So this is going to be, right, we're going to have 2x to the squared divided by 2. Okay? Now again, with definite integrals, we don't have to add c because they'll end up subtracting away later anyway. So you don't even need c. So we always use this big bar at the end because all we've done is we've done the indefinite integral. We haven't done the definite part. So this tells us that we still have to plug some stuff in. So what we do here is we plug 3 in, and then we plug 1 in to our equation, and we subtract them from each other. So this one we are going to get, now the 2's cancel, so you're just left with x squared. So we get 3 squared minus 1 squared, which should equal 9 minus 1, which gives us 8. So this number represents the area under the curve of the function 2x between 1 and 3. So we get an area of 8 for this. Okay, so let's make it a little bit more complex. The integral from 0 to 6 of the square root of 4x plus 1. So we need to integrate 4x plus 1, but before we do that, we need to make sure that we have it in the right form, which we'll have it as 4x plus 1 to the 1/2 dx. So if we were to integrate this, we would end up getting, we would have our 4x plus 1, this would be to the 3/2. We would then divide by the 3/2, and then also we need to divide by the derivative of the inside, since it's a coefficient, which would be 4. And we do this from 6 to 0. Okay, so let's continue. If we simplified this, we would get 4x plus 1 to the 3/2 divided by, this should end up getting 6 on the bottom, and we're doing this from 6 to 0. So again, you plug your top number in first, and then you subtract away when you plug in your bottom number. So if I plugged 6 in, you're going to end up getting, this would be 24 plus 1, so 25 to the 3/2 over 6 minus, plugging in 0, we'd get 1 to the 3/2 over 6. So what do we get here? So 25 to the 3/2 is this up here. So here, hold on. So finding these numbers, that's the same thing as the square root of 25 cubed. So that's 5 cubed, which is 125. So I'm going to replace this with 125. And then 1 to the 3/2 is the same thing as just 1. So what we do end up with when we combine these together is going to be 124 6, which we can divide by 2, each of those. We get 62 over 3. And so this is the most reduced version of our problem here, 62/3. So let's look at a trigonometric problem. So the integral from 0 to pi over 4 of 3 sine of 2x. So we need to integrate 3 sine of 2x. Well, we'll have 3. The integral of sine is negative cosine of 2x. We then have to divide by 2 because of the derivative of our inside function. And then we have to do this from pi over 4 to 0. So I'm going to simplify this a little bit. So we get negative 3 cosine of 2x all over 2. And this is from pi over 4 to 0. So we need to plug in, again, our first number, and then we're going to subtract away when we plug in our second. So I plug in pi over 4, I get negative 3 times the cosine of pi over 4 times 2 is going to make pi over 2 divided by 2. And we subtract away negative cosine of 0, because 0 times 2 is 0 over 2. So we need to continue to simplify this. Well, the cosine of pi over 2 is 0. So this is negative. This whole thing zeroes out. Negative 3 times 0 over 2 makes 0. So we have negative times a negative makes a positive. The cosine of 0 is 1 over 2. And so we end up getting our answer to be a half. So the definite integral from 0 to pi over 4 of 3 sine 2x dx is 1/2. We can also do some of these kind of analytically. You know, what do we know? What if we looked at the derivative, okay, of e to the x squared minus 3x? Well, we know we're going to end up with e to the x squared minus 3x as part of it, because that's the way that e works. You don't lose any coefficients. But then we have to multiply by the derivative of our exponent, which is the derivative of our exponent is going to be 2x minus 3. So the derivative of this equals that. Well, how can we use that to figure out what the definite integral is of this? Well, we know that this comes from that. So that is what you would have if you integrated, leaving out the c. But we know that when we do definite integrals, we actually don't even need that. So if I want to find the indefinite integral of this, I'm going to use this function. So I'm going to be plugging in my 0 and my negative 1 into the function whose derivative this is. So you can see the connection here. So I'm going to be using this guy right up here. So if I plug in 0, I'm going to get e to the 0 squared minus 3 times 0, which is e to the 0, which is 1. I'm going to subtract away to the negative 1. So e to the negative 1 squared minus 3 times negative 1. That's e to the first plus 3, which is e to the fourth. And we just leave it like that. This actually we cannot simplify anymore. So we're just going to leave it as 1 minus e to the fourth. There's no problem in that at all. Now what if we had a problem, let's say, where it says what if we don't know one of our bounds? Okay? We can still figure that out if we know things about our derivative. So our integral, excuse me. So let's say we're going to integrate this. 3, so we have the integral of k to 1 of 3 over 2x minus 1 dx. So here, we need to turn this into an equation that we can use. So we notice that this is kind of a natural log type form. So we've been showing you guys to take 3 out. Now the derivative of the denominator is 2, so that needs to be up here. So we end up dividing by 2 as well, because these have to cancel each other. So we haven't really changed anything, we just made it look a little different. Well, this right here is the same thing as 3/2 times the natural log of 2x minus 1 Now, this we have to do from k to 1. So we need to go through and actually solve this the best that we can. So remember, we plugged k in first, and then we plug 1 in next. If we plugged k in, we would get 3/2 times the natural log of 2k minus 1 minus 3/2 times the natural log of 2 times 1 minus 1, which is 2 minus 1, which makes 1. And we know from the beginning of the problem that this whole thing equals 2. So let's use this towards our advantage. So we can't simplify the beginning part yet. Okay, so we've got 3/2 times the natural log of 2k minus 1. Now, what is this? So a natural log of 1. What power would I take e to get a 1 out? Well, anything to the 0 power makes 1. So this whole thing actually makes 0. So we can actually get rid of this altogether. So we end up with 3/2. The natural log of 2k minus 1 equals 2. So in order to solve this, I'm going to take this 3/2 and divide it over. So if I divided each side by 3/2, you should end up getting that the natural log of 2k minus 1 equals 4/3. And so now we can unwrap this because we're trying to solve for k. So we're going to say e, which is the base of the natural log, e to the 4/3 equals 2k minus 1. So we get e to the 4/3 equals 2k minus 1. And so if we were to solve for k, you would add the 1 over and divide by 2. So you'd have e to the 4/3 plus 1 over 2. Now this is our final answer. Now it looks kind of strange, but because we had a natural log form, it's not surprising that this is the type of answer that we're going to get.